All right, so we kind of, in general, done some things. And you guys that are working on the that first graph, I want you to stay with me and go back to that. Okay. All right. So, trying to make this really nice and neat, so it's really, really clear. So, regarding the graphs of sine and cosine, we've in general talked about this a little bit so far, but I want to kind of formalize the stuff that we've discovered. So one thing about the graphs of sine and cosine is both of them oscillate. Both oscillate or move up and down between two values. And that's between -1 and 1. Okay, so that's super important to remember that at their most basic, they stay between -1 and 1. And so in general, let's sketch this real quick. And all you're going to do, you're going to get really used to drawing these, hopefully. I don't want to do it like that. I would like to draw it with my special tools. Let's see where my graph is. Ink to shape. Ink to shape. Let's see if this will. I just want to draw a little red. Just like that. Well, that'll have to do. All right, and basically what I'm going to do is I'm just going to put a really neat graph of sine on here. So let's say every 2 spaces will be pi over 2. So I'll do 2 notches. And it's going to be better for you if you kind of space it like I space it. So notice I've got 4 tick marks. Pi is at the second one, and then 2 pi. And the graph of sine in general will look like this. We'll start at 0, and then we'll go up to 1, and then we'll come back to 0, and then we'll drop down to -1, and then we'll come back up to 0. And so it'll kind of look like this. I'm going to draw it as neatly as I can on this. So what I don't want to see is like that, right? There are no sharp ends in sine or cosine. And so now let's talk a little bit about the vocabulary that we kind of started developing yesterday. And so let's talk about this. And that's going to be our amplitude. We call this amplitude. And that's basically the distance from the midline to the crest or the trough. Right, just so from this midline right here, either up here, and notice it's the same exact thing down this way. And it doesn't really matter which one you're doing. They're in my desk. Right, so that's amplitude. And then we have this other kind of metric that we look for, and this is the period. And so that is from 0 to 2 pi for this one. So that's the period from here to here. And then we'll define it in words too. So this will be the period of the function. And this is just the length of one full cycle. Length of one full cycle or wave, whatever. And that'll change based on how horizontally stretched or smushed it is. But just a few general facts about sine and cosine and the amplitude and period of those functions. Before we start transforming these things, for sine and for cosine, a couple of basic facts. The natural amplitude for both of these functions is 1. Because they go up to 1 and they drop down to -1. And their natural period, how long does it take these to cycle?
2 pi.
2 pi radians. Or in degrees?
360.
360. Natural period. So 1 full rotation around the circle, we interpret that as 1 full cycle of the wave. That's going to be 2 pi radians. Right. So just general things that we will need to know later.
Can you scroll up real quick?
Sure.
Just look at it.
Don't feel bad. I wouldn't make you write them. This was like the second time I've written these today, so I'm sorry that you're having to write so much, but at least you didn't have to write it twice. Yes, it's a win. All right. If you have to go back, we can go back and fill in gaps. So general form, Lord, I can't spell. General form, and I'm just going to use sine as an example, and this is the general form of the function, would be f of x equals a times sine of b times x minus c plus d. And so you may recognize some of the parameters a, b, c, and d from when we were transforming other types of functions before. Right, we had a number multiplied out front. We had a horizontal shift c, and we had a vertical shift d. And this is very much the same thing. The only thing that gets a little weird here is b, and we'll talk about that in a minute. Right, so you have all of these parameters. These are the things that we're going to talk about, and we will need to know what they do to this general form of the wave that you just took a quiz over. That's why I need you to really be familiar with those, because we're going to be doing a lot of calculations from those starting points. And it's going to be really tedious if you're not familiar. So let's talk about amplitude first. So this is, I'm going to draw a star, because we're going to start a new kind of section here. We're going to talk about, in general, amplitude. The amplitude is given to us from the function by taking the absolute value of a. Do y'all remember what absolute value is? It makes it positive, exactly. Very good. So, and another important fact is when a is less than 0, what does that tell me about a? What is it? If it's less than 0, it's negative. When a is less than 0, aka a negative number, based on what you saw before when we were transforming functions, what do you think it does? What? What does it do to the graph? Flips it. Yes. When a is negative, it reflects over the x-axis. So that we called that before. We called that, flip. So the amplitude is the positive version of the number, but there's also the added bonus of it will flip the graph. Okay, just like we saw before. This is a vertical stretch. And it can also reflect the graph. Let's do an example. And this is really kind of an exercise in organization. So I'm going to show you how I organize it. So state the amplitude is the first thing I want us to do in this example. And then I want to show the amplitude change in the graph. On the graph. Okay. So let's say it's going to have a part A with sine and a part B with cosine. So let's say I've got this function f of x equals 2 times the sine of x. All right. So, this is a. And so, the amplitude is given by the absolute value of a. And so in this case, the amplitude is just 2. That's pretty simple. And so now to graph this, I'm going to need to make an XY table. And I want it to be horizontal. That's usually kind of the best way to go here. So we're going to draw this. And then below it, I'm going to draw another one where I'm going to actually put the graph. Okay, so the first thing I want you to do, because this is just a lot of different calculations, and they do get quite complex after doing so many of them, is, hold on, let me erase that. All right, so the first thing I'm going to do is I'm just going to say, okay, if I can get my pen to show back up, be patient. So this will be x, and the first thing I'm going to do is write the values for plain old sine x, which is basically y, right? So for values of x, that'd be 0, pi over 2, pi, 3 pi over 2. These are my important ones, and 2 pi. So what are the values of sine at these places? Well, that's 0, 1, 0, -1, and again 0. Okay, so this is basic sine graph. But now, see, I've done something to it. I actually have 2 times sine x. And so what I'm going to do is I'm going to multiply all of these values by 2. 0 times 2 is 0. 1 times 2 is 2. 0 times 2 is 0. -1 times 2 is -2, and then 0. So I don't want these anymore, right? I don't want to use these anymore because I've got new ones that I've transformed. So now I've got x's and y's, and so this is going to be fine. Let's say this is 1 and this is -1, and let's say that, again, like before, I'm going to make tick marks like this in general, and this will be, pi, and I'll call this 2 pi, and that should really be about all I need to get this done. All right, so let's graph original sine, because I asked you to show me the change, right? So that's fine. So I'm going to make just little x's in red for the original. So that'd be 0, 1, 0, -1, 0. And I'm just going to show you, original sine. I'm just going to kind of make it with a dotted line so we can see the difference. And now in blue, I'm just going to graph the rest, the new values, right? So 0 is still 0. Pi over 2 now goes all the way up to 2. At pi, we're still at 0. At 3 pi over 2, we're now all the way down at -2, and then we're still at 0 here. And so this is the transform graph. Notice it's just been stretched by a factor of 2 vertically. I don't like that. Questions so far? Okie dokie. Let's do, and remember, understanding and being on track with what I'm doing is more important than writing, because we can always go back and write later. Or you can print these notes. I do not care. All right, so for this one, notice I have a different a now. Now I have a negative value for a, but that's okay, because the absolute value of -3 is just 3. So this is the amplitude. The amplitude of this function is 3. So I'm going to go back and I'm going to do the exact same thing I did before. I'm going to draw an XY table. And then I'm going to draw this right here. Oh, golly. That's terrible. Please, can this space, and you can kind of anticipate, like I know I'm going to need 3 blocks because I know it's going to be 3 up, 3 down because that's the amplitude. And the more you do this, the more you'll be able to anticipate what your coordinate grid needs to look like. So this will be x, and this will be cosine of x, and this will be -3 times the cosine of x. Because I just want my original values first. So that's going to be 0, pi over 2, pi, 3 pi over 2. And for cosine, that's 1, 0, -1, 0, 1. So these are my originals. And now I'm going to make this edit. So I want to take, in this next line, I want to multiply all of the y values or the cosine values by -3. So this will become -3. This will become 0. This one will actually become +3. This one stays 0, and this one will be -3. So let's show the change on the graph again, and just like before, I'm just going to make my little tick marks. Kind of get a grasp of where pi and 2 pi are. And then in red, I'm going to do the original values. That'll be here, cosine, 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 cosine. And then just showing you what the original cosine graph looks like. And now let's go back and, we don't need these because that's the original function. We want the transformed function. And then I'm just going to plot x's and y's, right? These are basically, the x's, and these are basically the y's. New y's. So let's do that. So this will be actually -3 now, way down here. At pi over 2, I'm still at 0. At pi, I'm all the way up at +3 now. Then 0, and then -3 again. So notice I have a couple of things that have happened here. Not only did my graph stretch vertically by a factor of 3, but it also flipped, just like we talked about. So even though we do not include the negative in the calculation of the amplitude, it still matters when you're sketching the graph. Like we still have to take it into account when we are transforming these points. And of course, we know that this would just continue on and on, even though we're just drawing one instance of the wave. Questions about amplitude? No? I don't think that's it. All right, well, that's amplitude. I'm going faster than I thought. Let's do the change in the period. This is the one that usually aggravates people the most, because it's the only one that you can't just straight up pull off the graph. So this is the period change. Remember, the period is how long it takes the graph to make one full cycle. We'll call this a period change. Ooh, that's getting on my nerves. All right. Please work, pen. All right, the period change is dictated by the parameter b. The period change is not b. It is dictated by the b value. So the way we get the period, so period of the function equals, we take the natural period. Remember, we discussed that at the beginning of the notes. Just want my technology to work. That's all. My natural period divided by b gives me the actual period. So for sine and cosine, what did we say the natural period for this was? 2 pi. So why don't I just write 2 pi? Well, there are other trigonometric functions that have other periods, right? So like tangent has a period of pi. So that's why we just say, in general, the natural period divided by b gives me the new period. And so let's do one. Maybe. Maybe we will. Who knows? All right. So let's say we want to state the period. I'm going to sling it through the window and you just call her and tell her I quit if it doesn't start working.
Before you quit, you go try hard.
If I quit, I will leave party to you because I won't leave. That's all yours. You can lead the class until someone gets here. So maybe if I move closer to it, I don't know. It's not this, it's this program. I should probably, did you get this? Show the period change on the graph. On the graph. Okay. I have like infinite patience with everything but technology messing it up. Nothing makes me more angry than that. All right. So let's do f of x. And I want you to notice, remember where the parameter is located. And when I say parameter, I mean the weird number. So notice now it's inside and multiplied by the x or the angle. So here's b. And so first thing I asked you to do is state the period. So the period, the normal and natural period of sine is 2 pi. And I want to divide by b, which gives me a new period of pi radians. So the period for this function is half as long. Half as long. So the formula for the period is to take the natural period of the function and then divide it by the b value. And so you can kind of think of this as if we're working inside of the parentheses, everything is backwards. See, I've got a 2 multiplied, but it really cuts the period in half. So it kind of does the opposite of what you would expect when you're inside of the parentheses. So let's see if I can sit back over here. All right, so the next step, let's actually graph it, and to do that, we need an XY chart. So I'm going to draw my XY chart. I'm going to draw my little grid here. And I'm still going to mark it pi and 2 pi. I'm going to mark this 1, and this is still going to be here I've got x. And then remember, my parent function is sine x. That's what I want to do first. I want 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this will be 0, 1, 0, negative 1, 0. Okay. Now, instead of messing with the output values or the y values, things inside the parentheses actually change the x values. Okay? So instead of recalculating these, I'm actually going to recalculate these up here, and this is actually going to be x divided by 2. Remember, we do the opposite. If this is multiplied by 2, I'm going to divide the x values by 2. And so this will be 0, this will be pi over 4, this will be pi over 2, this will be 3 pi over 4, and this will be pi, which is exactly what I expect, right? If my new period is in fact pi, I would expect to get a full cycle there. All right? So now I don't need these guys anymore. I have new ones. So let's do the original, just to note like how different it's going to look. So for regular old sine, I've got, that's cosine. All right. So for regular old sine, I got 0, I got 1, I got 0, I got negative 1, and I got 0. So that's this guy. So let's just see what happens here. Let's graph this one in blue. So now I've got 0, 0 still. And then I've got pi over 4, 1, which, if this is pi, this is 1/4 of that. So I'm going to go here. And that's going to be all the way up at 1. Then I've got pi over 2, which is here at 0. 3 out of 4. 3 pi over 4 is down here. And then at pi, I've made one full cycle. There we go. What I was trying to do there. There we go. So this is equivalent to what we did when the wave was half as long. Right? And now we were just kind of formalizing that process a little bit more. And now notice, I remember we talked about a period being one full cycle of the wave. One full cycle. And now you see that we've made one full cycle in half that distance. Good. All right, let's do one with cosine. Let's do one with cosine. So see what I mean now, why you want the graph paper, it's just a pain to do it without it. So let's say we've got f of x of cosine of x over 3. So if over here the b value was 2, the b value here is actually 1/3. Right, because I've got my little imaginary 1 sitting here. B is multiplied, in our definition, B is multiplied by the x, so not divided, we're not talking division here, we're talking multiplication. This is multiplication by 1/3, which is equivalent to division by 3 in practice, but we're talking about a multiplicative relationship. So let's say we find the period in the same way, and so the natural period of cosine is 2 pi, b is 1/3, so we divide by 1/3, which is the same as 3, so this would be 6 pi is the new period. So notice, if this is 1/3, it's 3 times as long. So it's that inverse kind of weird backwards relationship that we saw before. So let's go again. Take our table. We'll do regular cosines. It'll be 0, pi over 2, pi, 3 pi over 2, 2 pi. Cosine is 1, 0, negative 1, 0, 1. And so remember, here we had 2 times x and we divided, but here we've got what's essentially division by 3, so I can really just say 3 times x. Do the opposite. If this is divided by 3, then I'm going to multiply by 3. This would be 0. This would be 3 pi over 2. This would be 3 pi. This would be 6 pi. I skipped because it's easy. And this would be 9 pi over 2. And now I don't need to. All right, let's draw and get ready to do this. I'm going to, when the period change happens, sometimes you're going to want to edit your tick marks. And so I'm actually going to edit mine to where this is pi. Actually, no, I don't think that. It's going to take too long. You'll do the same thing. You'll be like, no, I don't really like that. No, I think I do. This will be pi. Yeah. Oh, so frustrating. That's why it says on the syllabus to bring a pencil. Pencils have erasers. Let's see. 2 pi, 3 pi, 4 pi, 5 pi. Another reason I like to show you kind of how I think about things is so that you're not shocked when you have to start over. Because you're kind of like, because if you just start out with, the pie, you're going to end up with a graph like this long. And who wants that, right? Like, nobody wants that. That's aggravating. And why do you think I chose, just since we're talking about it, why do you think I chose to leave two tick marks between every hole in front of the pie? Because these denominators are twos, right? So I know I'm going to have a halfway point at some level. Right, so that's just me thinking about parts of whole numbers. If these were threes on the bottom, I would have left three tick marks. And you could have always just kind of eyeballed it halfway through, but I mean, I just really don't want to. Like, do you ever like have one of those days where like all the little things are just making you want to set something aflame, or like blow something up? That is what I'm dealing with today. Like, it's one of those days where when I leave, my sweater is gonna get caught on the doorknob, and I'm just gonna completely have a miserable.
There's another thing that's on the video now.
It's good. It's good. This is really it. And, we're not gonna pretend. So, I mean, do y'all not have bad days like this?
I do.
Okay, so 10 out of 10 can relate, so it's okay. I, believe it or not, I am a person, not a robot. Strange, I know. Please do not speak to me if you see me in Walmart. It's embarrassing. All right, let's talk about this particular graph. Listen, it is not terrible. It really isn't. You're like, oh gosh, fractions, I do not like them. We do not think like that. And here we're like fractions. Fun times. So let's take a look. Let's do original first. Let's do the original cosine. That's 1. It's usually pi over 2, right?
Yes.
Okay. And then we'll go here and here and here. Okay. So you notice I had to really kind of think about what my cosine looks like. There we go. So that's my normal cosine. You make it in dotted lines. Like it was. Just so my notes are dotted lines. All right, now let's go in blue. 0, 1. Dang, that didn't even change. Now 3 pi over 2, where is that?
Pi into the
Yes, it's right here. So we're going to be at 0. Then at 3 pi, way over here, we're going to be down at -1. And from here, you can probably pick up the pattern if you know what cosine looks like. It's going to be, me, in my brain, I go all the way over here, and I'm like, all right, let me split the difference. There it is. Because I know it's symmetric. You don't have to think about it like that. You'll kind of come to your own understanding about how you want to deal with that. But that's the way I think about it. I know this thing is symmetric about certain points. So, there you go. Notice how it's stretched way out. And again, just to highlight the differences in the periods, this is the period of the original function versus the period of the new function. So it's stretched considerably. A lower frequency, if you will. All right. Let's do, we got 2 more left. We got 2 more transformations left. All right, now let's talk about a vertical shift. If I'm working with a vertical shift, do you think I'm going to be editing x coordinates or y coordinates? Y coordinates, because they go up and down.
Thank you so much.
So the vertical shift is dealt with the parameter d. And d gives us the new midline. So the midline is expressed as an equation, y equals d. So let's go again. We want to graph the function. And I also want us to label the midline. We briefly talked about the midline yesterday. And so let's go let's be f of x, it's gonna be sine first, so this will be sine of x plus 2. So you have, if I'm gonna move this up by 2, I should probably leave a considerable amount of room at the top. Right, just thinking a couple of steps ahead. So this will be 1. I'm not changing anything horizontally, so I'm pretty safe just to label it like I've been labeling it. This will be x. This will be sine x. 0 pi over 2. You see why I needed you to memorize these? Because it's just over and over and over again. 0, 1, 0, -1, 0. You told me you were going to mess with the y's because it's vertical. And remember, when we're doing things with y, we just, do exactly what it tells us to do. We're going to take sine x, so we're going to add 2. And so this would be 2, this would be 3, this would be 2, this would be 1, and this would be 2. And now I don't even need these. Just for funsies, I'll graph the original. Lines. And so 0 becomes 2. 1 becomes 3. And then 0 becomes 2. This one becomes 1, and this one is 2. And so there's your shifted vertically sine. And there's your midline, and we label that as y equals 2. And this is the parameter of this one. Just shifted it straight up. This one was like intended to be tricky, I guess, but I feel like we're gonna get it. There we go. So what's D? Yes, in example B. What number is D? -1. It doesn't matter if it's over here. It is the constant number added to the function. That's what it is. Because you could rewrite this as cosine x minus 1. So we can understand that D in this case is -1. So can you go ahead and tell me the new equation of the midline? Y equals -1. Like, if that's all I asked you, you wouldn't even need to graph it. It wouldn't even matter. But we will. We'll do it real quick. This is x. This is cosine x. And this is -1 plus cosine x. So this will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this will be 1, 0, -1, 0, and 1. And then subtracting 1 from each of these values, I'm just going to get those. I don't need these anymore. I'm going to go down, so I should probably leave more room on the bottom. This is 1. This is -1. Pi. 2 pi. Alright, the original will be in red. That's here, 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 and here. You're going to be so happy to jump on Desmos when we finally get on there. Alright, so this one is just going to be, this one becomes 0, this one becomes -1, this one becomes -2, this one becomes this, and this. Smiley face, and those things. And just like we suspected, the new midline is at y equals -1.
How bad did we do?
All right, I got one more, and that is the parameter c. one more.
I think we
What,
made-
baby? You know you can pull this up on your Chromebook.
Yeah, no, I just.
Okay. I'm just making sure. All right, this is called the phase shift, which is a fancy name for a horizontal shift. Yeah, y'all get as much of this as you need. I like my hands all bald. All right, and the phase shift is C. And so we want to state the phase shift and graph it. And then graph the function. All right. I think I'm going to do one of these. So now we'll have f of x equals sine x plus pi over 4. So this is C. C is kind of hidden because if you recall the general format, A sine bx minus c plus d, notice sine is negative. I mean, not sine, but it is subtraction. This is addition, so c must actually be negative pi. So based off what we did before with transformations, am I going left or right?
Left.
Left. Remember, we do the opposite inside of the parentheses. And so again, we're so sick of drawing these, because I'm sick of drawing these. It's cool though. We're gonna make it. Oh, that's really sad. Okay. All right, so I got x, sine of x, 0, pi over 2, pi, 3 pi over 2, and 2 pi, and this is 0, 1, 0, negative 1, 0. Inside of the parentheses, also this is a horizontal shift, so do I mess with the x's or the y's? The x's. This is affecting the x. So this will actually be x minus pi over 4. Remember, we do the opposite inside the parentheses. So this would be 0. Pi over 2 minus pi over 4 is just pi over 4. Pi minus pi over 4 is 3 pi over 4. Is that right? Ooh, this one's tough. So this would be, I don't know. I might be in my calculator with this one. 3 pi over 2.
7 pi.
Is it great?
7 pi.
7 pi over 4, thank you. I got 5 pi over 4. Oh, the last one maybe is 7 pi over 4.
Yeah, the last one.
Oh, look at the pattern. They're going up by 2. Yeah.
Well,
Okay, cool. Lots of patterns.
Wait, how does 0 minus pi over 4 equal 0?
Nice job. Yeah, always ask. Be negative pi over 4. Good job. All right. Well, these are in 4s. Yes, ma'am. Oh, yes. Go ahead, dear. You're fine. I'm going to give you this before you go. On your way out. You will be happy to know that on your assignment, I did give you grids.
you did.
I did. I know. Figure we've suffered enough. Thank you, ma'am. All right. So now let's draw the original just because. I'm going to think about this one for a second. If I've got fourths here, I'm going to, I'm going to put pi here. And then I'm going to put 2 pi over here. And then I should probably, what would go right here?
Measure negative pi over 2.
Negative pi over 2. Or you could just go 4 and do negative pi. I don't really care. Whatever. I just didn't have room. All right. So the original is, what it always is. And I'm going to draw it just so you can see it. This is this, this, this. And now we'll go here. So this will be negative pi over 4, which would be 0. Then I'd have pi over 4 would be 1. But I mean, since we're just shifting it by 1 unit, you can kind of tell where it's going. Once you get it started, you can kind of tell where it's going. Notice we just went left. Pi over 4. See, we just shifted to the left that point. And that's the phase shift, because if you're talking about waves being in phase with one another and how they're phasing, it's kind of how they're doing this behavior. Here's a fun fact. I'm just going to leave it just like that.
Yes.
I'm going to leave it just like that. Here's a fun fact about phase shift. Sine of x is equivalent to cosine of x minus pi over 2. So if you shift cosine to the right pi over 2 units, you will have sine. Because if you remember, they're only a little bit off. They're about 90 degrees away from each other. That might help you later. This is important.
Wait, what was the fun fact?
The fun fact is that a phase shift of cosine will give you sine. These are equivalent. I got one more example that's important. I know.
Get a new paper.
Yeah, get a new paper.
It doesn't.
All right. This is multiple transformations at once.
Wait, what?
Multiple transformations at once. I showed you each individual thing. Now I have to show you multiple.
Yeah.
You missed Desmos yet?
No.
Oh, no? Okay.
I'm kidding.
Multiple transformations. So, when you are doing things to y, you follow the normal order of operations. When you are doing things to x, you do it backwards. Sad myth. Sad myth. It's just pen myth backwards. You just go in reverse. So these go together, these go together, these go together, these go together. Okay. So let's do one. So let's say I've got f of x. I'm not going to actually plot it. I'm just going to do the table because I feel like we've plotted enough stuff. And I know you know how to plot points. Let's say, notice this is two things occurring to the what? The x's or the y's?
No wise.
What you think?
One of each.
Are you guessing or are you actually like?
I'm guessing to see if you can have a reaction.
I'm stone faced.
No, just one. Because whenever you go happens.
So these are both happening to the y. This is an amplitude change and this is a vertical shift. So you need a big old table. Here we go. X, sine x, 0, pi over 2, pi, 3 pi over 2, 2 pi, 0, 1, 0, negative 1, and 0. Okay, so I'm going to do both y things. Now, following the order of operations, what will I do first? Multiply by 2 or subtract 1?
Subtract one.
I will multiply before I subtract.
Oh, it's y, not x.
Yes, y not x. So we're gonna do this first, and then we're gonna do this. So the first thing I'm gonna do is 2 times sine x, 0, 2, 0, -2, and 0. And then I'm gonna take those values and subtract 1 from them. -1, 1, -1, -3, -1. So I went through 2 iterations. Now, could you do both of those things without writing an extra line in the table? Yes. I'm just trying to show you step by step what to do. And when you look back, you'll be able to follow what I did step by step. In practice, you could just multiply by 2 and then subtract 1 in one step. That's cool. As long as you do it in the correct order, okay? That's why it's important to know whether you are changing x's, which is inside the parentheses, which is B and C, or outside, which is A and D, because it's going to happen differently. All right? So these are no longer valid. These are no longer valid. These are my x's and these are my y's. And then you'll just plot it. And you will have stretched vertically to an amplitude of 2, and you would have shifted down 1. So let me ask you a couple of quick questions just from the function without seeing the graph. What is the amplitude?
Y equals -2. Y equals -2. It's 2.
Amplitude is given by the,
It's just 2.
correct. The amplitude is 2. Now, those of you that were just answering me, what is the midline?
Y equals -2.
Y equals -1. Correct. Huh?
I was just
Okay, what is the period?
2 pi.
2 pi, and the natural period, there's no b to change it. All right, and then what is the phase shift? That is the horizontal shift with c.
There is
None. There is no c. All right, so these are all of the characteristics that you'll need to identify eventually, both from just the function and from looking at the graph. So we still have like, I don't know, 15 minutes. No, I'm gonna let you work on this. Because it's 9 problems, and then 2 write the function. Tomorrow I'm going to teach you to match my graph on Desmos, and then I'm going to teach you 2 brand new functions that have like asymptotes and stuff that you've never seen. We'll do secant and cosine tomorrow, and they're super weird. So I'm going to give you these and the graphs. There's 2 out here. All your stuff is separate. That's why I'm like,
It's hard.
it's just been weird. That's a double-sided graph.
Are you sure?
Got 6.
How many do we need?
2.
So it's okay.
Yeah, you better not.
We're doing next one like that.
Got two functions.
Oh, yeah. And you bring the board to. She was saying.
What do we need? 3?
Did they change? That's what they changed.
I don't have it back.
You don't have it.
Yeah.
I thought I was gonna be smarter than this.
You didn't like tell them how
I'm not. How does this work?
And I wrote them clean and then it
There you go.
Oh, I thought you were gonna use the same word.
No, I'm about to use this.